Hello everyone, welcome to this video in set theory concepts. In this video we're going to talk about slightly advanced concepts related to the Venn diagrams. So we've already done a basic video explaining 2-circle Venn diagram and 3-circle Venn diagram. If you have not watched it, we strongly recommend you to watch it before we get into this concept, where you're slightly extending the concept to find out the maximum and minimum inside these Venn diagrams. So first let's focus on the Venn diagram with 2 circles. So let's assume an example like this. So we're talking about a number of students who are playing football in a school and the number of students who are playing cricket. So that's like, this is the blue circle and this is the red circle, and the total number of students in the school is U. So that's the entire rectangle that we're using to represent. Right. So let's give some variables like X, Y, Z and A. So X is the number of students who are playing only football. Y is the number of students who are playing both football and cricket, and Z is the number of students who are playing only cricket, and A is the remaining students in the school who are playing neither cricket nor football, right? That's how we have split this. So what will be the number of students who are playing football? That will be X plus Y. So only football, both football and cricket, and the number of students who are playing cricket will be only cricket as well as students who are playing both cricket and football. So that will be Y plus Z, and the total number of students in the school will be X plus Y plus Z plus A. That is the total number of students, right? This is the basic thing that we discussed in the earlier video. Now what could be asked, as we have seen in that video, there are four variables X, Y, Z and A. So we definitely need 4 equations to get a definite value for all the variables X, Y, Z and A. Right? So sometimes the questions would be very straightforward, sometimes they would not give you that, they would give you only 3 clues, so you would be able to write only 3 equations, based on which you should be able to actually calculate multiple possibilities for given set of values. So in that case, they would rather ask you a question talking about, let's say, what is the maximum number of students that are playing both cricket and football. So I don't know the exact value of Y based on the given information, but from the given information I can give an approximate estimation which would say this will be at most the number of students who are playing both the games. This would be the minimum number of students who must be playing both the games to satisfy the given set of clues. Let's talk about an example like this. The same example, there are 100 students in a school, out of which 80 are playing football and 60 are playing cricket. How many students are playing both the games? If I ask you this question, what would you do? 80 people are playing football, that means X plus Y is 80, and Y plus Z is people who are playing cricket, and X plus Y plus Z plus A is 100. So these are the only clues I have. So let's say I add these 2 equations. What would I get? X plus Y plus Z is equals to 140. So X plus Y plus Z, and I pull it together, plus Y. So what is X plus Y plus Z? I use this equation, so I send A this side. X plus Y plus Z is 100 minus A. So this will be 100 minus A plus Y is equals to 140. 100 goes this side, so minus A plus Y will be 40. So this is where I am stuck. I don't know the value of A, so I cannot find the value of Y. That's why the question would not ask you what is the value of Y. Basically, how many students are playing both the games. It could be anything. If let's say I say there are 10 students who are playing neither of the games, then automatically what will be Y? Y will be 50. If there are, let's say, 5 students who are playing neither of the games, so what will be Y? That will be 45. So what will be the maximum value of Y? So Y is basically 40 plus A. So as much as as high as A can go, that will give me the maximum possible value for Y. Can A be 100, 1000, 10,000? No, right? These are not possible. Why? Because I already know there are only 100 students in the school, so there can't be more than 100. So X plus Y plus Z plus A is 100. So I cannot have A more than 100. Why? A could be 100 in a way. I can agree with that. Like, none of the students are playing both the games or any of the games, so X can be 0, Y can be 0 and Z can be 0. That makes A as 0. But we have some other information which is also denying that. So I cannot make A as 0. What is the maximum value that I can go for A? That is 20. Why is this 20? Because I know that 80 people are playing football. So if 80 people are playing football, let's assume the remaining 20 out of 100 students are playing none of the games. Right? So that is the maximum it can go. Can I have A being 21? If A is 21, that means 79 people, only 79 people must be playing one of these two games. That will not agree with the given fact that 80 people are playing football. Right? Cricket is less in number, that's why we are not worried about it. So how would this picture look like? I'm saying A can be maximum 20. The picture would look like this. There are 80 people who are playing football, and within 80 there will be 60 people who are playing cricket. That means there will be 20 who are playing only football, and there are 60 who are playing both cricket and football, and the remaining 20 will be playing none. So that is why this is the maximum case. So 40 plus 20 is 60, right? Y is 60. That's what I said. 60 people are playing both. What is the worst possible case? I make A 0. Is that a possibility? Yes. How would I make it? What does that mean? A is 0, so Y is 40 automatically. So that gives X as 40 and Y Z as 20. So there are 40 plus 40, 80 students who are playing football. There are 40 plus 20, 60 students who are playing cricket. And what is this value of Y? 40. So that's the minimum value. I cannot go beyond that. If I make a two circle overlap like this, where let's say there are 60 people who are playing cricket, there are 50 people, or there are 40 people who are playing football, 60 people are playing cricket, 40 people are playing football, cricket, and then there are 20, right? So because 60 plus 20 has to be 80 who are playing football, 40 plus 20, 60 is the number of people who are playing cricket. What is the sum of this 60 plus 20 plus 40? 120, which is more than 100. Again, this is wrong. That's why the circles cannot go beyond 40. That means they should be overlapping 40 at least. Or it can be more than that, and it can go only up to 60. So 40 to 60 is the range for Y. It could be 41, 42, 43. All of them are possible. Right? So we have done a very detailed discussion on this. So be careful, while you solve this. So let's solve an example to understand this better. So of the 300 members at a gym, 150 use the strength room and 100 use the cardio room. So there are 300 people in the gym. So 150 are using the strength room and 100 are using the cardio room. If at least 30 of the members do not use either. So what is this basically giving? At least 30 of the members. It's not saying 30 members are not using, it's at least. Then the number of members using both strength room and cardio room must be between. So they're asking basically the maximum minimum value for the number of people who are doing both. So let's assume like this. So two circles, strength and cardio, X, Y and Z, and then A is the people who are doing nothing, neither. Right? Do not use either of them. So what will be the simple equation? X plus Y plus Z plus A must be 300. Right? All these individual values. That's one equation I should be able to write. 150 is the strength room. The strength room is X plus Y. And 100 use the cardio, that is Y plus Z is 100. And what is another clue? They are saying there are at least 30 members. So A should be greater than or equal to 30. It could be 40, 50, 60, I don't know. It could be any number, but it should be at least 30 members who does not use both equipments. Basically, none of the equipments are used by these 30 people, or maybe more than that. I need to know that. So because of this uncertainty, though it looks like we have 4 equations, they are not actually 4 equations, right? We only have 3 equations, and this is an inequality. If it was A equals to 30, we would have got a simple answer. Right, that is basically only giving us one set of value for unique value for X, Y, Z and A. That would have been a different and easier question. Because it says A is greater than equals to 30, it could be 30, 31, 32 and so on. So I can have multiple values for X, Y and Z as well. So let's try to do the same thing. I'll add these two. What do I get? X plus Y plus Z is equals to 250. X plus Y Z is, A goes this side, so it is 300 minus A. So I'll replace this here. 300 minus A plus Y is equals to 250. So this goes this side. Minus A plus Y is equals to minus 50 is what I'm getting. So this is what I got as an equation. Y should be A minus 50. So I know from the given condition that A should be greater than or equals to 30. So I cannot give A as 0, 1, 2, 3 and so on. It has to be 30 or more than that. Can I give A as 30? That is agree with this, but there's a problem with that. What is that? Then y will be minus 20. I cannot have negative values for any of this, right? I cannot have minus 20 people using both equipments. So A has to be at least 50, then y will be 0. So this is the case where I have minimum 0 number of people who are using both. So what will that situation look like? See, I have 150 people who are using strength, and then I have 100 people who are using cardio, and so there is no touch overlap between these two. So 100 plus 150 is 250. I still have another 50 members who are doing nothing, right? You are using neither of these two equipments. So 150 plus 100 plus 50 is 300. That's satisfying this. So in this case, I can have 0 number of members who are using both the equipment. That is an acceptable or possible situation. Now what will be the maximum case? So y is a minus 50. So if I increase a to as high as possible, I will be able to get higher value for y, right? So as I said, can I give y as 300? Because there are 300 people in the gym, right? I cannot go beyond 300. Obviously, I cannot have more than 300 people because there are only 300 people at the gym. That is accepting with greater than or equals 30, but there's a problem. What is that problem? We've already discussed that. I know that 150 people are using the strength room and 100 people are using the cardio room. So which one is bigger? 150. So I cannot have 300 people who are using neither of the equipment, because I know as a matter of fact 150 people are using the strength room. So the maximum I can have for A is 150. If A is 150, how does that figure look like? So there are 150 people who are using the strength room, and there are 100 people who are using the cardio inside the 150. Right? Then I'll have 150 people outside this 150 who are doing none of this. Basically, we are not using either of these two equipments. Right? Are you understanding it? I'll just repeat it again. Let's imagine there are 150 people who are using strength room, and these 100 people who are using cardio are also part of this 150. That is possible, right? So in that case, 150 people are using the strength room. Anyway, in the 150 only 100 people are using the cardio room. So there are 300 people in the gym. 300 minus 150 is 150 is the number of people who are using neither of the equipment. So that means A is 150. So how many people are doing both? This 100 people who are using the cardio are also using the strength room. So Y is A is 150. 150 minus 50 is 100 is Y. So the maximum number of people who would use both would be 100. The minimum can be 0. So the answer is basically I can have between 0 to 100. As simple as it. Right? So this method is not something that I always recommend, but you should understand what we are doing. Right? If you're comfortable with this, that's good. Otherwise, when you're talking about maximizing, minimizing it, imagine it like this. If you are trying to maximize the value of the y, the overlapping zone, that is this, when will this happen? In this case, that is the smaller value completely sits inside the larger value. Automatically that will be the overlap. I cannot have 101 people who are doing both, because there can be only 100 people who are using cardio, so there is no way 101 people will use both. So these 100 people are inside this 150. That's how the situation would look like. That is the maximum case of the overlap are using both. When will I see the minimum case? When they are completely away from each other. There is no touching between them. But sometimes it might not be possible, because I only have, let's say, 100 people in the gym. Or okay, let's imagine situation like 200 people in the gym. The same question. Can they do this? No, right? I need 150, 100, 250 people in the gym to have this complete separation. Because I only have 200 people in the gym, I cannot have that. So what will I see then? I will see an overlap, right? And this overlap plus this will bring me 200. So that would look like, let's say this will be 100, 50 and 50. So 100 plus 50 is 150, 50 plus 50 is, so that is one of the case that I can see, right? So that will be 200, right? I cannot do anything beyond this. If I try to adjust, it will, like, let's say if I do 120, what should be this? This should be 30. So what will I have? I'll be left with 50 to have 120 plus 30 plus 50, 200. But 30 plus 50 is 80, which is not agreeing with this 100 people doing the cardio. So that is how you should do. But you can always do from this case also. But just be careful. That's what you need to look at. When you want to minimize the overlap, try to put them as far away as possible. When you want to make them with a maximum overlap, then keep the smaller circle completely inside the large circle and you'll get the answer. That's how you can do it in the diagram way. Otherwise, you can also do the equation way, whatever suits you. So let's focus on the 3 circles in this. Something similar, let's assume the football, cricket and basketball are 3 games. There are X people who are playing only football, Y people who are playing only cricket, and Z number of students who are playing only basketball. Let's say this is P playing both football and cricket, Q is both cricket and basketball, and R basically both basketball and football. And let's say T is the number of students who are playing all 3 games. So how many, now what's the number of students who are playing football? X plus P plus T plus R, right? Similarly, cricket is P plus T plus Q plus Y, and basketball would be Z plus R plus T plus Q, and the total number of students in the school would be X plus Y plus Z. That's only 1 game, exactly 2 games, and all 3 games. That's the total number of, and I also need to give A, that's the students outside, so that will be counted as A, right? Altogether we have 8 variables, so we need 8 equations, but they don't give it. So that sort of again makes it a complicated situation. So let's actually dive into the problem solving directly to understand how to deal with this 3 circles, maxima and minima. So in a school there are 3 sports available, and at least 1 sport is compulsory to select. 80% students selected cricket, 70% selected football, and 60% selected basketball. So with this clue, and what is the question asking? A student can select 2 or 3 sports as well. What is the minimum and maximum number of students that selected all 3 sports? That's the same thing that we are interested in, the minimum and maximum. So imagine a figure like this. This is how the normal situation looks like people who are playing cricket, football and basketball. 70%, sorry, football is 70, right? 80% is cricket, 70% and 60% is what they're saying. And what is the first minimum number of students that selected all 3 sports? So the minimum is that I want this to go as small as possible. Can I make it 0? What about this, the A? Let's talk about A first. That's A is the number of students who are playing neither of these 3 games. None of the 3 games. That is 0, right? Why? Because it said at least 1 sport is compulsory to be selected. So that's basically making it easy for us. So this is 0. So how would I make it a minimum possible case? If I draw a diagram, all the 3 circles are not touching each other. Is that a possibility? 80% playing cricket, 70 football and 60 basketball. What do I get? 80 plus 70, 150 plus 60, that is 210%, which is more than 100%. So that is wrong. I cannot have 3 non-overlapping circles like this. So what is the other possibility then? I have overlap like this. So there is 2. So P, Q, R is there, but I have there is no T. So then I have all 3. So that is also another possibility where I can make T 0, right? But the rest of the things would split the given percentages. But that is also not a possibility always, right? So let me show this part. X, Y, Z, P, Q, R and call it T. Okay. So if I say there are 70% who are playing football, in this situation I know that there is no one who is playing none of the games, right? So that is A is 0. So if 80% are playing cricket, so this is cricket, that is X plus P plus T plus R. What will be the remaining 20%? That will be this 3, right? They must be playing football or basketball or both. That's how it will be, right? Because I know that there is no student who is playing none of the 3 games. I mean, who is playing 0 games. He has to play at least 1 game. In that case, if I know that cricket is 80%, that is this circle is 80%, automatically this Z, Q and Y must be 100 minus 80%, that is 20%. There is one equation. Similarly, I know football is played by 70%, then x plus r plus z must be 100 minus 70, 30%. And similarly, I know basketball is played by 60%, that is this circle. So if this is 60, the remaining zone should be 100 minus 60, 40. So that is taken by x plus p plus y. So x plus p plus y is 100 minus 60, 40%. So these are my two equations. If I add 3, what would I get? X plus y plus z plus z. So that is 2 times x plus y plus z. P plus q plus r, and that will be 20 plus 30 plus 40 is 90%. Right? What do I know? I know that x plus y plus z plus p plus q plus r plus t is 100%. That's everyone, right? X plus y plus z, p plus q plus r plus t. I know a is 0, that's why I get this. So what is x plus y plus z plus p plus q plus r? 100 minus t. So I replace it here. What is this equation? Plus x plus y plus z plus p plus q plus r. So entire this is replaced with 100 minus t. This is equals to 90% rot. That's what we said. So x plus y plus z is 90. So I'll replace this part with 100 minus t. So that will be 100 minus t. So x plus y plus z minus t, or rather let me say 90 here and send minus t and everything to that side. So that will be 100 minus 90 is 10 equals to t minus of x plus y plus z equals to this. So that is how the final equation came, right? So I am trying to find the minimum value for t. So if I have t 0, what will I get? XYZ, can it be minus 10 to give me 10? No way, right? So that means t has to be 10 and x plus y plus z can be 0. So if t is 10 and x plus y plus z is 0, that is when I will satisfy this equation. That is the minimum possible situation. I cannot bring t less than 10. If t is 9, what should be this? This has to be minus 1 to get minus of minus plus 1, that's 9 plus 1, 10. But x plus y plus z can never be negative, right? So that's why that is absolutely a not possible case. So t has to be 10 and x, y and z can be 0. So what did we observe here? Finally, I made x, y and z 0 to minimize t. So what does that mean? That means this is not a possibility, always not a possibility, as I said. So what will this situation look like? X, y, z are 0. Then P and Q and R are taking the maximum thing. So that will look like this. So I know 80, 70, 60, right? The circles will look like this. This is 60% basketball, right? It's difficult to show with a diagram, but understand it something like this. This part is 0, this part is 0 and this part is 0. So this part, right, 2 people, this part 2 people and this part 2 people is taking up this 70, 60 and 80, right, to sum it up to 100%. How would that look like? Let me just show an example. For example, right, take this example, right, this is 0, 0, 0 and 0. P is 40, R is 30 and Q is 20 and T is 10. So the figure would look like this. Let me just rub it off to explain the same thing. A slightly different color. Right, this is the entire rectangle we are talking about. As I said, to minimize t, the goal would be to make the singles 0, right? That is how you can start any problem. Then this P, Q and R, P, Q and R would be as simple as this. Q is 20%. How did I get Q as 20%? See, P and R are part of football, right? And I know there is no one who is playing only cricket or only basketball. That is how we start off, okay? That is how we can easily solve the question. If I am trying to find the minimum number of people who are playing all 3 games, the first step you need to do is minimize the single games as 0, 0 and 0, okay? Then what will I do next? See, the football is played by 80%, sorry, cricket is played by 80%, sir. I'm always mixing this up, I'm sorry for that. cricket is played by 80%. If cricket is played by 80% and I know this is 0 and remaining, what will be the remaining? That 20% should be this 0 plus Q plus 0 and I know this is 0 and this is 0, so Q must be 20%. Similarly, football is played by 70%, which includes P, Q and T. So these three are already part of the 70%. Automatically R must be the remaining 30%, right? 100 minus 70 is 30%. Similarly, P will be 100 minus basketball is 60%, so 40%. So both cricket and football is played by 40%, football and basketball is 20 and cricket and basketball is 30. 40 plus 20 plus 30 is 90, so T has to be 10%. Right, that is how you solve a question asking you the minimum number of students that are doing all three things. Step 1, make the single entities 0, that is only cricket, only football, only basketball, 0, 0 and 0. With that, when I know there are 80% people who are playing cricket, the remaining people must be playing none of the games and playing both the games. And I know this is 0 in this case, so automatically the Q will be 20. Similarly, I find R and T to be 100 minus 70, 100 minus 60, 40 and 30%. Once I add all three of them, what do I get? 90%. So where will I get the remaining 10%? That will come from T. That's how you should do. That is how you should do for minimum. So when the question is asking for the maximum, right? Let's say the question is asking you to find the maximum number of students who are playing all three games. The thing that you need to do in that case is this. Let me explain this. So when would I maximize all three? When they overlap as much as possible, right? So imagine this, if the 60% of people who are playing basketball, right, is part of the number of people who are playing football. This is football, this is basketball and this is cricket. So 60% are playing all three games, so that's also playing basketball. Then there are 10% of people who are playing football and cricket but not basketball. So that is 60 plus 10, 70% are playing football, and then I have another 10% who are playing cricket only. See, it might not happen always like this, but this is slightly easier case, that's why we're getting like this. Understand, 60% playing all the three games, then 10% are playing football and cricket but not basketball. So that's basically 10%. So basically 60 plus 10, 70% playing football. And then there are 10% of students who are playing only cricket. So that is 60 plus 10 plus 10, that is 80% of them are playing cricket. But then in this case, what's flaw? We are not agreeing to the fact that at least one sport is compulsory to be selected. We are getting that 20% of students are playing none of the games. So this is going to mess up. That's why there is a wrong, answer for this question basically. This would have been a correct answer if the question did not give us this particular thing. So let me make it slightly different. So we need to push it in such a way that the 20% is also occupied, right? So let me redraw it. Because of that condition, how would I do? Let me do this thing. So let's call this T, right? So as much as possible, I'm trying to overlap the center. Okay, this is, let's call the common area as T, okay, even though I'm not doing it well. So if this is T and if I'm trying to maximize T, how would I do it? Let me call this as X, Y and Z, and this is P, Q and R, right? The same equations would work out. I would get X plus Y plus Z, P, we need to make T also, right, into this. So let me write this like this. So X plus P plus Q, R plus T. This is playing only cricket is 80. Similarly, I do Y plus P plus Q plus T is 70. And R plus T plus Q plus Z is 60, right? I have written the individual sports and I know the total X plus Y plus Z plus P plus Q plus R plus T must be 100. So there is no A, right? So if I try to solve all of these equations and I am trying to maximize T, how would I do it? So I add all these three equations as I always do. So X plus Y plus Z plus P plus Q plus R plus T is 100. Then you will be left with 1 P plus Q plus R plus 2t is equals to 80 plus 70 plus 60, that is 210. So I send it this side, so I'll get p plus q plus r plus 2t is 110. My goal is to maximize t. To maximize t, what will I do? I'll make this 0. It can happen, right? There is no overlap, like p, q and r is 0. Then 2t is 110, t is 55. This is the maximum that I can get. So again, to repeat this, what did I do? I write these individual equations, 80%, 70%, 60% with this, all of this. I added this 80 plus 70 plus 60. So left hand side would be x plus y plus z plus p plus q plus r plus p plus q plus r plus we see 3 times t. So I can replace this entire zone with 100. Then I'll be left with p plus q plus r plus 2t. And the right hand side is 80 plus 70 plus 60 is 210. So that will leave us p plus q plus r plus 2t is 110. So to maximize t, I am making this entire part 0. It can't go less than 0. So that case t gives me 55. So if you are trying to imagine this as a diagram, this is how you should see. Whenever, see how we have talked about minimizing t, we have started with single entities being 0, right? That's what we thought, x, y and z are 0. So there is slightly different way, but almost similar way. What should you do with this question when I'm trying to maximize t? Is start with the dual, basically the zones where there are two things overlapping, make them zeros. So let me call this to be t, okay? That's the overlap of all 3 circles. That is students who are playing all 3 sports. Playing exactly 2 sports, 0, 0 and 0. Cricket, football, basketball. If I know the entire cricket is 0, 0 and t, what will be this? I know cricket is played by 80%, right? So 80 minus t, 80% minus t. So 80 minus t plus t is the circle is 80. Similarly, if this is t, this must be 70 minus t and this must be 60 minus t. Right? Now I know the outside is 0 because at least one sport is compulsorily selected. If I add all of this plus this plus this plus 0 plus 0 plus 0 plus t plus 0, that must be 100. So that will give me 80 minus t plus 70 minus t plus 60 minus t equals to 100 plus t, sorry, this t is also there, right? So that will give me 210 minus t minus t minus t is minus 3t plus t, so that is minus 2t equals to 100. So 2t goes this side, this gives me the same equation. I'll get 2t equals to 110 and t is 55. This is the maximum case, right? So to find the maximum number of students or whatever it is with all the 3 overlaps, there's 2 overlaps will be 0. This is the center one, whatever the maximum value you're trying to find, call it x, t or any variable, automatically find the 80 minus t, 70 minus t, 60 minus t sort of it. Add all of this equals to the 100 or whatever the total number be, and you should get the t value, as simple as it. Right? That's how you can do it in an easier manner. I've always explained it using the fundamental equation format so that you understand why we are doing whatever we're doing, right? To find the maximum number of students, we are minimizing this dual circles, I mean the overlaps of 2 things, 0, 0, 0. To find the minimum number, what we will do? We made the single entities 0, x0, y0 and z0. So p, q and r will be the maximum, which will be these individual values, right? What will be p? Which is basically not including r and q. 100 minus this circle will give me p. What will give me q? 100 minus this circle value, right? That's how we find p, q, r, and using that p plus q plus r plus t must be the total, and that will give us t. That is the easier way to solve it, right? I've explained it in a very detailed manner. If you're still confused, look at this, understand this technique that I've discussed at the end of each concept, so that at least you'll be able to solve the questions in this format. But understanding them through the diagrams, equation format, and then getting this technique is the best way to understand, so that you can actually solve even slightly complicated and different types of questions that could be faced or framed in this area, right? Thank you for watching this video. If you're watching this video in the YouTube channel, make sure that you check out our full-length courses available for free at gtcube.com/store. We're also coming up with a lot of content, and all the updates are shared over our partners Facebook page, facebook.com/gtcube3. Also, don't forget to subscribe to the channel. We are coming up with a lot of content that would help you in your preparation. So do subscribe and follow us to get all those notifications. Thank you, and let's meet in the next video.